Hello, Miss Eric.
Hello.
Are you alright?
Yeah.
Okay, so I give you a list, yeah? 1, 2, 5, 7, 9. Okay, and now I will give you another list. This is one list. Let's call it A. Another list which is 2, 1, 9, 7, 5. Okay. So now the task is that this is the original list, and you can pick any sublist, right? What is sublist? Continuous sublist, right? Sublist.
Can we pick the whole thing?
Yeah, we're on sublist. And then you can reverse the sublist as many times as you want, okay? Reverse it as many times as you want.
And then you have to make the same.
Well done, wow, you see this is going, and can you make this to this?
But what if you can't?
If you can't, then you return false. If you can, then you tell me it's yes.
You switch these two and you switch these three.
Yeah, so first of all, here, the sublist, and then you sublist, okay. Okay, so you got it. Okay, so if I tell you that, okay, I'm going to write it another way, okay. 7, yeah. Can you make it? Remember, reverse sublist as many times as you want.
Well, you could.
Yeah. So it's hard, yeah, but
Wait. I think I can do it.
yeah.
Reverse these 4.
Yeah, these 4. Yeah, it becomes 1, 2, 5, 9. Okay, I know what.
7, and then you switch 9 and 7.
Yeah, okay, so that becomes 7, 9. And then, wow, you did it. Wow. Okay, so yes. So how can we solve this problem? Reverse sublist as many times as you want. It's a very, think about the thing. Look, if I don't care about others, if I want to move this to the end, a number to the end, or to any number position, how would you do it? How would you do it? If I don't care about others, if I want to move this 9 to the end,
You need to move it,
yeah.
and you do the whole thing opposite,
Okay, and how about moving here?
and then it'll be 7, 1, 2,
Yeah.
5, 9, and then you will need to switch 1 with 7, and then you need to, yeah.
Okay, so if I tell you that I just want to move 9 to the end, but I don't want to touch any orders of these. So these will be 5, 2, 1, 7. So it will be like 5, 2, 1, 7, 9. Okay, so how would you do it?
If you want to move,
If I want to move this 9 to the end without changing the order of the other elements, it's 5, 2, 1, 7. You see 5, 2, 1, 7. How would you do it?
but can we change it and then we put it back again?
Up to you. I mean, can you think
Can
about?
we?
Yeah, of course. As
Yay!
many as times as possible. So
Yay!
how would you do it?
Let me allow me to introduce.
Yeah? How would you do it?
Wait. A sec. Please let me think. So.
Yeah, think about it. So the other elements won't change. I just want to move this to the end.
I know. So you move these two, move it like that.
Yeah. Well done. So let's call bubble. Yeah, bubble. Yeah. Yeah, you.
Bubble.
Yeah, bubbling up. Yeah, bubbling up. That's what I want. So basically, so I can prove that I can move this element to any positions I want. Right? Right? Okay. So the task becomes that to check if it's possible to move any of these, to rearrange these to the target. So in order for these to become these, what kind of requirements do we need to make sure these two arrays? For example, these two arrays needs to have the same length, right? Alright?
Oh, yeah.
Yeah, that's one obvious. Yeah, if it's different length, you can't make it, right? Okay, so same length. And how about others? Same length. How about if I have a million here, 100, and this doesn't have 100? Can you change to the target?
Huh?
The elements needs to be the same, right?
What do you mean?
Look, if I have a 15 here, I don't have 15 here. Can you change from A to B? So if one of the elements is not found in another, if one of the element is not found in other list, what happens? Can you change? No, you cannot change, right? So for example, 15, no matter how you swap reverse, you can't make it the target, right? Because the target doesn't contain the 15, alright? Yes? Alright? Okay, so what kind of characteristic these two array needs to be? Remember, we talk about, checking two strings if they are, what?
The same.
They are the same after the arrangement. What do we call that? What do you call it? Like,
What do you mean?
you know what I'm talking about. Like,
I get it what you mean.
like, okay, let me give you an
You're
example.
like this. Blah, 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 blah.
Like, RICE,
Rice.
ERIC. Okay, so
Anagram.
anagram. Okay, so what's anagram?
Is when if you got the same amount of letters, same character in each word, and
Same frequency for each character. Okay, so basically we're checking the same. So the length needs to be same. Each number needs to be the same number. If they are, okay, they are two twos, and here needs to be two twos, right? Yeah. Alright. That's 17. Here needs to be 17. Okay. And how can we check if the anagram? Do you still remember? Instead of anagram, we're checking the anagram of the list of two lists. Yeah. So how can we check if two lists are anagrams? Huh? So basically, we are checking the list are anagrams. How can we check it? Define. Let's just check. Okay. There are two lists, A and B.
Hey, wait, I think I got an idea, but it might not work.
Okay, so how do you check if two string are anagram? We talked about this before, right?
I know. Wait. I know how to solve a problem you're talking about, say before, and so basically, you just check if they have the same amount, and they have the same amount character, and if it doesn't have any, and you can just return true if all of that is okay.
Okay, so first of all, we want to check it with length, yeah? If length A not equals length B, then what should we do? Return. If the lengths are different, do false, yeah? That stands for the anagram, yeah? If the two strings are different size, they come to the anagram, right? Yeah? That's not possible, right? Alright? Yeah. Okay, now, so how can we check if two strings are anagram? It's basically the same. How can we check if the two strings are anagram? We can what? First of all, we can do what? We can do this thing in O and log n. How can we do this?
Sort?
Yeah, we can sort it, yeah? If we sort it, what happens?
They'll be the same.
They will be the same, yeah, exactly. Return, how can we sort it? Sort it, we just say sort it. A equal what?
B.
Huh? We want to sort it both.
Sorted B.
Yeah. Okay. What's the time complexity?
O and log n.
What's the space complexity?
O1.
Okay. Another thing is that, remember we talk about the one star we see, the notebook. What's that? Remember I use that a lot to counter. Yeah. We count. If we use the counter A, then it could look if this is 1, 2, okay, and another one is 2, 1, okay. So what counter A? What does counter 8 give us? It will give us this. 1, 1. 2, 1, yeah? 2 appears one time. 1 appears one time, yeah? And here, counter B, what does it equal? 1, 1, 2, 1, right? So they are the same, right? Yeah? So I can replace sorted with what keyword? I just told you, come on.
Count.
Yeah, counter. Counter. Just replace it with counter.
I like to put sorted.
Wait, counter. If you counter, what's the time complexity?
O-N.
Yeah, what's the space complexity?
O-1. O-N.
O-N. Okay, so which one is better? Which one is faster?
So
Which one is faster? Counter or sorted?
this one has O1, this one has O-N, but this one has O-N.
Yeah. Which one is faster? Counter or sorted? Counter is O-N. Sorted is O-N log N. Come on. That's really obvious. Which one is faster? O-N or O-N log N? Come on. Easy.
This one is bigger, this one is smaller.
Yeah, so this one is faster, yeah?
But what about the space?
Okay, space. Which one uses the more space?
This one.
Yeah, because this one, O1 is constant, this one. Okay, so the trade-off, yeah? Yeah, the balance, yeah? It depends on what you want. Yeah, you see, we're just changing one keyword from counter to sorted.
I think this one is faster.
No. O-N log N. O-N log N bigger than this one. If it's bigger, the complexity is bigger, then it's slower. If it's smaller, right? If it's O1, it's faster, right? Than O-N, right? Remember, we talk about complexity. The smaller number means
What's the
faster.
difference between O1 and O-N?
O1 means that no matter how big of this number, this array is.
I mean, what's the difference? What's the
What?
You can explain.
What's the difference between O1 and O-N? Or what? What? Come on.
I don't know how to explain.
So what's your question? Come on. Look. I'm writing a table here, okay? So here, that's time, that's space. Okay, if we are using the counter, we're using the sorted. So this one, time is O-N. Space is O-N. Sorted, time is O.
N again.
Yeah. Space is
O1.
okay. So this one sorted is slower but use less space, memory. Counter is faster but use more space. Okay? Got it? So the lower this complexity, the lower, the better for both time and space. It would be great if both time and space is O1. What does it mean O1 constant? Means that no matter how many elements, if this element is a million, it doesn't matter. It's still O1 instant fast. O(n), remember we talked about y equals x, yeah? Yes, the other day? Yeah? Y equals n. So what does it mean? Here. The n is here. This is y equals x, right? Alright? And what's y equals 1?
Y equals 1. I think it's something like.
Which line is it? Can you draw y equals 1 here? Come on.
Wait, is it? I think it's something like this.
Yeah. Because y, this is y, right? This is x. This is we call it n, okay? Look, x is n equals no matter how many element is it is still 1. This is constant. This is constant, okay? This is constant. Let's linear. O(n) log n. I don't know how it's drawn, but it will be O(n) squared. Yeah, when n is 1, it will be 1. When n is 2, it will be 4. So it will be something like that. Okay? So look, if n is a million, it will be that high.
It's like this. So when it's like this, it's like why is it still 2?
No. I'm just drawing something like that. So 2 it will be 4, and 3 it will be 9. You see, you will go in very slow, very how do you call this? Slope, yeah. Very high. Steep, yeah, steep. Okay? But constant is no matter how big a million n is still 1. Okay, we love this kind of solution. Yeah, it doesn't. The number of the number of the input, the scale of the input doesn't impact the solution, right? Got it? Does it make sense?
Yeah.
Yeah, it makes sense. Yeah. Okay, that's it for today.
Bye 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 bye
Bye bye.
bye bye bye.